Hello viewers, welcome back to Library Premium Consults. In today's video, we are going to take a question on correlation and regression. So as you can see on the screen, I'm about reading. University students who graduate with a very good cumulative average marks have high expectation of getting good jobs after completion. Gene Etten Consult collects information on cumulative average scores for graduates from different tertiary institutions and their respective monthly salaries in dollars after getting a job. The table below summarizes the information above. Use the table to answer the question that follow. So we have the average marks that was collected by Gene Etten Consult, and we have what their respective salaries after getting a job. So the examiner is asking us to work in two decimal places, right? So using a simple linear regression equation of the form y is equal to alpha plus beta x plus e, where alpha is the y-intercept, beta is the slope, and e is the error term, we are asked to find I, the values of alpha and beta. Interpret the result from I above. What will be the salary of a graduate who obtained a cumulative average mark of 0 in school? IV, predict the salary of graduates who had an average mark of 55. And then V, estimate the Pearson correlation coefficient and interpret. VI, estimate the coefficient of determination and interpret. And VII, differentiate between correlation analysis and regression analysis. And VIII, list two properties of correlation coefficient. So these are requirements that we are asked to use the table to actually come out with it. So please follow through carefully so that we go through them right away. So since we are told to find the values of alpha and beta, and you know from regression equation, we have y to be equal to alpha plus beta x, right? Plus the error in term, right? This is not something we're going to work on it right now, but we are going to focus on the alpha plus beta x. That's going to be our emphasis in this particular case. So let's take note of that. But to find alpha, the formula is y bar, which is what the mean of what y values, minus beta, which is the slope, and then multiplied by the x bar, which is what the mean of what x values. All right. So before you can actually come out with alpha, you must know the beta, which is what the slope of this equation in this particular case. So the coefficient of what x bar, the coefficient of what x in this particular case. So to find the beta 2, the formula says, which is the slope, it says that to find the beta, it is what summation x y minus n into bracket y bar multiplying what x bar, all right, all divided by summation x square minus n, then x bar all what squared. This is how we also come out with what the slope of the regression equation, summation x y minus n into bracket mean bar multiplying what, that is y mean bar multiplying x mean bar, all divided by summation s square minus n multiplying what x bar or what squared. So this is how you also calculate what the slope of what the regression equation. So having to gotten these formulas down, we should be able to produce what a table that will help us to get a column for what xy, get a column for x square, get a column here. So xy and x square, and even a column for x and a column for y, so that we can calculate the mean of x and the mean of what y in that particular case. So that is another thing that we need to know in this particular case. So let's jump into our table. So these are the columns for the x values from the table here, and then the y values to use also from this table particular case. So that's what we have here. So per what we are asked to find, we are asked to, and per the regression equation, we are asked to find what alpha, which is what y bar minus the beta multiplying the x bar, is slope, right? And then to find the slope, it is what this particular formula, okay? But before we can find alpha, we need to know what the slope in this particular case. So we need to produce other additional columns so that we can easily find the slope of the equation. But we can first of all find what the x bar and then the y bar. It's a matter of what summation of what all the x values divided by the number and summation of all the y values divided by the number, so that we get the mean for x and then the mean for y in this particular case. So here we are going to find the summation for x and that of what y, right? So we know that summation x and that of what summation y. So with my calculation, I had a total summation of x to what 833, and that of summation y, I had a total of what 1395. So therefore, to find the mean of x, the mean of x is going to give us what summation x over n, and the mean of what y should give me summation y values over what n. But we know the total number here is what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10. So n is what 10. So all that we're going to do here is say that here is what 833 divided by 10. Then we do same for y. Do same for y. We do same for y. But is going to give us what? We know the total was what 1395. So 1395 and then divide by what 10. So at the end of the day, we should be able to get the mean for x to be what 83.3, and that of what the y to be 13.95. So that's going to be our mean in this particular case. So having to be gotten our mean, the next column we want to produce is to produce a column for x, y, because per the slope formula, or we have summation xy. So we're going to have a column for xy, all right, and also have what x squared. So we're going to have another column for what s squared, and we also produce other columns as we move along in this particular case. So let's take a note of that. So you're going to work on the column xy and then x squared, all right. So you come back here and then you have a column with a name called xy. So here all that we are trying to do here is to multiply what individual what values from x and y, so that we get a column for what xy. Is that okay? So here when you take 65 multiply what 120, 71 multiply 150, 75 multiply what 100, in that order till you exhaust the list. So this is the column for the xy. So you have 7,800 and then follow suit to the last what value. So here you need to find what the summation of what the xy. So you're gonna write here to be your summation xy, and that should give you, per my calculation, I had a total of what 117,630 as my total what sum for x, summation x and y. So let's take note of that. So having we gotten that of xy, let's go back to our formula for finding the slope. So you have satisfied what this column, you have also satisfied what the y bar and then the x bar, right? So you are left with what the x square. You are left with the x square, but you already have what a column for what x. So it's a matter of what squaring what individual what values for what x, so that we get what a column for x square. So you're gonna have a column for x square here. So you have what x square here. So that is a column for what x square. That's a column for x square in that particular case. So in that, you also want to find what the total sum for what x square. So you're gonna have your summation x square, and that should fetch you a total of what 70,423. 70,423 in that particular case. So once we're able to satisfy the requirement here for the formulas, we can straight away start with finding what the various what values, that is the alpha, which is the y-intercept, and then that of what the slope, which will be represented as what the beta. So we have beta to be equal to summation xy. So let's look out for summation xy in this particular case. And in our column, we have summation xy, which is what 117,630. So you have that one within here. So that's going to be 117,630 minus, and we know n in this particular case was what 10. So right here to be 10 multiplying, and we know that of what y bar to be equal to, let's check, y bar was what 13.95. so you're gonna have here to be what 13.95 multiplying what x bar to be what 83.3. all right, so that's what we are talking about here. After that, we divide all by x squared. So let's look out for our summation x squared on the table. So summation x squared on our table was what 70,423. 70,423. So you're going to have that one here, 70,423 minus, and we know our n here is what 10. Okay, and then multiply by the summation. So we then multiply by what x bar. We know x bar was what 83.3. So once you have 83.3 here, you squared it, so it becomes what 83.3, then you squared it. So once you get to this stage, it's a matter of what your calculator to get your final answer for the beta in that particular. That is the slope of what the equation. That is the slope of the equation. So here I had here to be 1.3795, but we were told that in the question, examiner told us to use what 2 decimal places. So therefore we're going to say that it's going to 1.38. That's in 2 decimal places because of the 9, so making it to 2 decimal places, and then we are good to go. So this is going to be the slope of the equation. The slope of the equation to be equal to 1.38. So once we've gotten the slope of the equation, then we can as well find what the alpha, which is what the y-intercept, for which we know the formula is what y bar minus our slope multiplying what our x bar. So we know that of our y bar to be equal to what 13.95, right, minus our slope in this case was, so we are going to pick what this one, we are going to pick 1.3795. so that's going to give us what 1.3795. okay, and then multiply that by our x bar, so which is equal to 83.3. So here is a matter of what your calculator. Okay, so here 139.5 minus 1.3795 multiplying 83.3 should be able to fetch you alpha to be equal to 24.587, and then that. So since we are told to work in 2 decimal places, that's going to give us a 24.549. So that's going to be for the y-intercept, or the constant of what the regression equation, which is denoted as what as alpha. So once you have done with that, that is the I part of the question. The I is saying that we need to interpret the result from what I. So therefore we can have our regression equation. We can have our regression equation y to be equal to, alpha to be equal to 24.59 plus beta to be, or the slope to be what 1.38. 38 and then multiply by what? X. So this becomes what? Our regression what? Equation. It becomes our regression equation in this particular case. So we are asked to interpret the results from the I above. So with the interpretation, this is how it's going to be. We know from the regression equation, we're told that y is equal to alpha plus what? Beta x, right? Where we know that b is the slope and we know the alpha is the y-intercept. By y-intercept, we mean that when we substitute x to be equal to 0, the result should be equal to what? A, or alpha, alpha. So 24.59 is the constant value or the intercept of what? Y in the equation. So with this, we can interpret the alpha, which is what? Which is 24.59 to be the constant of what? The regression equation or y-intercept. This means that is the value at which the average mark of a graduate student is what? 0. What does that mean? What does that mean? If the average mark of a graduate student is 0, that will primarily means that if I substitute what? X to be equal to what? 0, that should fetch me what? Y to be equal to what? 24.59. So that is the interpretation behind. Meaning that if I substitute X to be equal to 0, I should be able to get what? 24.59. So that is for the constant or the intercept of what? The Y value. So with the slope of the equation, which we were told, or per our calculation, we had what? 1.38, tells us that it is the slope of what? The equation. And this is the value which decrease or increase the graduate salary whenever the student average mark what? Changes. What do you mean by this? We are saying that this value, it is, which is what? 1.38 as a slope of the regression equation, is actually the value which decrease or increases graduate salary or whenever student average mark changes. What do we mean by this? Let's say we have two students average salary, so average mark to be, say, first one 65 and that of what? 71. You realize that if you are to substitute what? This value 65 into the equation, y is equal to 24.59 plus 1.38, right? The value you're going to derive after the substitution is going to be different from the result that we derive when we substitute what? 71 to the same what? Equation, because the values what? Differ. So that is the interpretation behind what? The slope, which is what? 1.38. This tells us that is the value which decrease or increases what? Graduate salary whenever the student average mark what? Changes, right? So that is the interpretation what? Behind the slope of the equation. So let's take note of that. Then we are asked to calculate or find what would be the salary of a graduate who obtain a cumulative average mark of 0 in school. So here we know, tell us that here I at x to be equal to what? 0. What is y? That's going to be question mark. So once we know x to be equal to 0, therefore from the regression equation, you can say that 24.59 plus 1.38. Then whenever you see a substitute what? 0 there, a number multiplying by 0 should fetch you what? 0. So therefore we can say that y is going to give us what? 24.59. So this becomes what? The salary that a graduate will obtain when his average mark is what? It's 0. Alright? So Ivy, we are asked to predict the salary of a graduate who had an average mark of 55. So that will follow the same trend as that of the III. So that's going to be at x is equal to 55. What will be the value of what? Y? That's going to be question mark. So we apply our equation. So therefore we can say that y is going to give us 24.59 plus 1.38 and then multiply by what? 55. So with that, we can therefore say that y should give us a total of 100 point what? 49. 100 point what? 49. 100.49. So this is a salary that a student actually will obtain when he gets an average mark of what? 55. Right? So that is the value of what? Y in this particular case. So V, we are asked to estimate the Pearson correlation coefficient and interpret. So the Pearson correlation coefficient is how the formula is. It is small r is equal to n multiplying summation x y bracket close minus summation x multiplying summation y bracket close, all divided by the square root of, all divided by the square root of, all divided by the square root of n multiplying summation x all squared bracket close minus summation x all squared multiplying into bracket n multiplying summation y square minus summation y all squared, and you have a bracket close. So this is how we estimate for the Pearson correlation coefficient. It is n multiplying summation s squared minus summation x all squared, all multiplying n multiplied by summation y squared minus summation x all into bracket squared. So here we have a new variable introduced here, which is what? Y square, but that is not captured on our table above here. So let's going to have that captured here so that we face it in our formula. But fortunately for us, we have a column for y. We have a column for y. So it's a matter of squaring individual values in y. We're going to have here to be y square. We're going to do the same thing as we did for that of the x square. So you take 120, you square it, you take 150, you square it, and you fill it in that order. So let's fill that. So this is going to be the values for y square in that order that has been filled here. Alright. And here too, you also need to find the summation of y square. So with that, it should be able to arrive at 210,325 as your total summation of y square. 210,325. So once you're able to get that, we can easily substitute in our formula here to find that of our Pearson correlation coefficient. So in this particular case, it's going to be, so we know n to be equal to 10, right? So 10 into bracket, and we know summation xy. In our table here, we can pick our summation xy. Why is it? Summation xy to be 117,630. So once we have that, you can come and place that one here. So that's going to be 117,630, right? Bracket close minus, and we also have our summation x. We also have our summation x in this particular case. We also have our summation s in this particular case to be 833, right? And that of our summation y to be equal to 1395. Okay, so that one to bracket close, and then all divided by the square root of, so let's see the square root, the value that is found within the square root. So we have n to be 10. Okay, we also have summation x squared. Summation x squared, let's go and pick that value from our table above here. Summation x squared is 70,423. 70,420. So we're gonna have it to be 70,423. Okay, so what that's written, you come back to summation x all squared. So that's going to be minus into bracket 833 squared. Is that okay? Bracket close there. Multiplied by put another bracket. We have what? Our 10. Then we also have summation y square. We just computed that now. Summation y square from our table is what? 210,325. 210,325. So that's going to be substituted here as what? 210,325. 325 minus. So we have also here to be what? Summation y all whole square. So that's going to give us what? 1395 squared. 1395 squared in that particular case. So here, with the help of your calculator, you should be able to arrive at r to be equal to 0.3538. But since we are told that the examiner told us to work in 2 decimal places, that's going to give us r to be equal to what? 0.3 5, because the 3 that comes after the 5 is what? Below what? 0.5. Okay, so we can run it towards 0.35. Tell us that it's in 2 decimal places. So the interpretation behind the Pearson correlation coefficient value here, where r is equal to 0.35, means that this is a weak what? Positive correlation between the average marks that a graduate student obtains and that of what? A salary after getting what? A job. So here, correlation help us know whether there exists a relationship between two variables. Okay, so this value actually tells us that there is a weak positive what? Correlation between the average marks and that of what? The salary that a student will obtain. Is that okay? Because we are told that r is always within the range of negative what? 1 to positive what? 1. So if we are talking about this 0.3, then it becomes what? A weak positive what? Correlation between the two variables in that case. So that's actually the interpretation behind this. And then VI, we are asked to estimate coefficient of determination and interpret. We are asked to estimate coefficient of determination and interpret. So let's see how we estimate coefficient of determination and interpret that. Let's see how we also estimate that. So to estimate, that's VI. To estimate what? Coefficient of determination and interpret. Coefficient of determination is estimated by the matter of squaring what? R. So it is r what? Squared. So once you get your coefficient of what? Pearson coefficient of correlation, you square what? That value. That should fetch you what? Your coefficient of determination, and then multiply by what? 100. So in this case, we know our coefficient of correlation to what? 0.3538. You square it and then convert to what? 100%. So that's going to give us a figure of what? 12.517. But in working in 2 decimal places, that's going to give us what? 12.52%. 12.52%. So this 12.52% coefficient of determination tells us the variability, okay, that exists between the average mark that the student obtains and the job that he can get at the end of the day, right? Or it tells us how much one variable influences what? Another, a proportion of what? A variable that influences another. That's what we call the coefficient of what? So meaning that 12.5% of the average mark can influence the amount of salary that a graduate worker can what? Earn at the end of the day. But note, correlation is not about what? Causation. We just want to know the relationship that exists between what? Two variables. So this is actually a proportion of percentage of what? Average mark that can influence what? The average salary that a graduate student will earn, and that is what? 12.5%. So we call this what? The coefficient of determination. It's a matter of squaring what? The coefficient of what? Correlation, then multiply by 100%, and you are good to what? Go. So let's take note of that. So we move on to VII. We are asked to differentiate between correlation analysis and regression analysis. So correlation analysis, as I've already indicated, correlation analysis has to do with where we want to find, or the statistical method that help us to find whether a relationship exists between two or more variables, whether a relationship exists between two or more variables. And to determine how much that relation actually exists is where we zoom our attention towards regression analysis. Regression analysis tells us to know the nature of the relationship that exists between two or more variables. So when it comes to regression, that's where we think of causation, where one variable causes another variable. So when it comes to regression, there is causation. But when it comes to correlation, there is no causation. We just want to know the relationship between two or more variables. But regression helps us to determine the nature of the relationship, and as such, it introduces a concept called causation for us to know the nature of the relationship that exists between two or more variables. So that's the distinction between correlation analysis and regression analysis. And then lastly, so here I refer from the notes. Then lastly, we also asked to list two properties of correlation. So what are some of the properties of correlation coefficient? What are some of the properties of correlation coefficient? So we're saying that one when it comes to correlation coefficient is always within the range of -1 to +1. So that's one property that we can talk about when it comes to correlation coefficient. Two is also that the coefficient of correlation measures only linear correlation, but between two variables. It's only measured a linear relationship between two variables. So the coefficient of correlation measures only linear correlation between two variables. As you can see here, where we estimated that R is equal to 0.35, you can clearly see that we're talking about just two variables, X and Y, where X represents the average mark of a graduate student, and then Y being the salary that he obtains for getting a job. So you can clearly see that it always estimates a figure that's between two variables only. So that is one properties of a correlation coefficient. If two variables, say X and Y, are independent, the coefficient of correlation between them will be 0. So that's another properties of a correlation coefficient. We're going to talk about coefficients of correlation are more independent of changes of origin. We have more to it when it comes to correlation coefficient. So these are the few tips that I can share with you. So one, it has a range between -1 to +1. Two is that coefficient of correlation measures only linear correlation between two variables. Three, if two variables, say X and Y, are independent, we are saying that coefficient of correlation between them will be 0. And lastly, the coefficient of correlation are independent of changes of origin, and a lot more. So these are the few things I can share with you. There are more to it that you can also search as well. So this is where we bring an end to our lesson on correlation and regression. So in our next video, we're going to introduce more questions for you to understand the concept about statistics. So I will see you next video where we discuss other issues. But please, if this was really helpful to you, please go ahead to smash the like button, subscribe to the channel, and share. So I'll see you in the next time. Bye bye.